I'm going to illustrate here is a class that I've developed to kind of represent a generic random event generator. So I'm going to have different kinds of outcomes that I can associate with this and different ways of selecting what the outcome is. And I'm going to make use of the abstract collections library that comes in the Python standard library to allow me to test more generically the different kinds of containers that could be passed into this, this class. So I have a class level function here called that just computes the cumulative probability, and it assumes I have a dictionary-like container coming in where the keys of the dictionary are the outcomes, the possible outcomes of the random event, and the values of the dictionary are the probability of each one of those outcomes occurring. And so I'm going to iterate over all the items. Remember, items are just the key value pairs as tuples, and compute the cumulative probability. In my constructor, I'm looking for 3 arguments. The first is the values, the random event outcomes, and they need to be a container type, which we'll go over a little bit more, a name, which will be just set to a private variable for the instance, and then a seed value if I want to set the random number generator for testing purposes, etc. So the basic structure here is I have this if, else. So the first thing I'm going to look for is it a kind of a mapping container? And then I'll do something. If it's not a mapping, is it at least a container? And a container would be, a set, a string, a list, a tuple, etc. And if it's none of those things, like I just passed in a number, then I'm going to raise a type error saying you didn't provide me a container type for my values. So if it's a mapping type object, like a dictionary, then there's 3 steps that I take here. The first is I have this self-select, and this is the function that's going to be called when I generate a random event, which you see, which is down here. It's an event, and it's just going to return some randomly generated result. So if it's a mapping type container coming in, so I have outcomes and probabilities associated with each of those outcomes, then I set the function that I'm going to be using to generate those random events is this method select cumulative probability. So select based on the cumulative probability, which I've defined down here. And it's kind of the standard approach that I've used in other code that you've seen. I generate a random number uniformly between 0 and 1, and then I just loop through all of my cumulative probability events and the cumulative probability, and if the randomly generated value is less than the cumulative probability associated with that event, then I return the event. If I manage to get all the way through my for loop without returning an event, then something's wrong, because the last element should have a cumulative probability of 1, and so I should have generated something that returns an outcome. Okay, so I'm setting what the function that I'm going to use here. Here I'm computing what the cumulative probabilities are for the value, the events that I've passed in, and then I'm storing in this variable vals just what the possible outcomes are. And these are the taking the keys of this dictionary-like object and converting it into a list. So if it's not a map, like a dictionary, but some other kind of container like a list or a tuple, then I go down this branch. And what I'm going to do here is I set my select function to be just select choice. And this just uses the random.choice function in the random library to randomly choose something from this container and return that. I don't need a cumulative probability for this kind of data, And so I'm going to set that equal to none. And then I'm going to just copy the values that were passed into these potential outcomes. And I do a copy because remember, if I just set self.double_vals to vals, it's just a pointer to the same location in memory. And if I change something on this, outside of this class, this values that I passed in, then I would be changing what's associated with the class. So I want everything in this class to be static after I've constructed it. And then the last remaining thing is just trying to come up with a kind of a nice looking way of printing out what the what this random event class contains. So what are the possible values that are generated? So I'm taking my possible outcomes, I'm converting that into a set so that I just have uniqueness. So like if I'd passed in a list with 1, 1, 2, 3, 4, 5, 6 to make a biased die where it's twice as likely to be a 1 than any other number, I don't want to show that to the user because the possible outcomes are 1, 2, 3, 4, 5, 6, even though the 1 is more likely based on how I passed it out. And then I'm converting that back into a list so I can index through it. I'm sorting it with whatever those values sort as, and then I'm converting them to strings. And I'm just going to make sure that I don't print more than 85 characters on a line so that I don't have kind of overflow from a kind of assumed base computer screen, and doing a left justification of the values that are printing out with some padding to a fixed amount of width. And then that just gets tagged in with the name that I provided for this event, and that's our class. So here I'm generating an instance of it that I've called process, and what I'm doing is I'm passing in the deck of cards that I've created before, and I'm calling it a playing cards. And so if I sit here and I run these events, I just get different randomly selected cards from my deck of cards. Now, when I print it out, it's sorting, and because I haven't provided any sort of specific rules, it's sorting on the numbers first. So you see we have all of our 2s, then 3s, 4s, etc. Now, what I want you to do, and this will be kind of further extensions of this, is to modify this class so that it's more robust. So for instance, if I pass in a dictionary of values and probability outcomes and probabilities for those outcomes, and the probabilities don't add up to 1, then this is not a valid description of a random process, so I should raise a value error when I go and compute the cumulative probabilities. Also, it'd be nice if we could get some sort of characterization from this random event of what kind of population of things does it represent. So we should add methods to get the probabilities that it would generate based on some n number of runs. And also we could characterize it using some simulations and then generating a pandas data frame that has what the mean and standard deviation and number of observations associated with it before. So those are future modifications that for the 2018 class will be part of a homework assignment. So here's another example where, okay, up here I made a deck of cards from it, and here I'm just going to make a six-sided fair die, so I'm passing in a list of numbers 1, 2, 3, 4, 5, 6. There are my outcomes. Oops. Zoom this back out. And I run it 1,000 times, and I get a distribution that looks like this. So all my numbers are being generated, but not uniformly yet because we've had a small number of simulations. If I do a few more, that's flattening out more, and I'm getting closer to the 1 out of 6 probability chance of occurring. In this example, I'm using this random event class to just create an unknown die. So I'm not telling myself what its values are, so I'm just going to randomly generate 10 values between 1 and 20, and then I can kind of infer what the results were by looking at the generated histogram. So you can see that some numbers were clearly not generated, and so the outcomes for this die are not uniform across all the numbers between 1